Okay, we're going to take a look at a data set and use some of the tools in Excel to summarize that data, both the center and the measure of variation in the data. Now, what we're going to look at is the point totals for Michael Jordan in the 1993 playoffs. And to get us a little bit inspired for that, let's take a look at Michael Jordan in the 1993 playoffs. All right, so now we're inspired. Let's take a look at what the data is. We have point totals by game, right? So there's 19 games that he played in the 1993 playoffs. Now I have lots of things filled in here. Part of them are, some of it is for figuring out standard deviation and median and range. I'm going to get rid of all of the results so that I can show you how we got to these numbers. All right, so let's start with just the sample itself. The sample is the collection of data. And when I put sample here, what I mean is the sample size. Now in Excel, the way you can count the number of things in a data set is, well, one way you could just highlight the data, right? And it'll tell me that there are 19. I could also just count, in this case, the games. There were 19 games. But there's another way. If you get a data set where you're not quite sure and maybe you need to count data in a number of columns, there's a systematic way you can do that. And you can do equals count and then highlight the data. And it will tell me that there are 19. And then the mean. How do we get the mean? Well, we've done this one before. Equals average of the data. And the median equals median. Now for range, there isn't a range function, at least in my Mac version. I don't know if they've added that into a recent PC edition of Excel, but there is a reasonably fast way to do it. You can just do equals max minus min, because the range is the maximum value minus the minimum value. So Excel will take those functions, the max function and the min function, and it will find the maximum value, the minimum value, and then it will subtract the two and tell me that the range is 37. So in the 1993 playoffs, Michael Jordan played 19 games. He averaged 35.1 points per game. His median score was, or point total, was 33.0 points per game, and he had a range of 37.0 points per game. So the difference between his lowest scoring game and his highest scoring game. Okay, so why don't we take a look at it from the median perspective and how we would talk about the data set with where our median is our measurement of center. In that case, what I want to do is make a box plot, get the 5-number summary of the data, make a box plot. Now you can make a box plot with Excel. So let me highlight the data here, insert. A box plot is a statistical graph, and so it's under the statistical graph symbol, and they call it a box and whisker plot. I think your book just calls it a box plot. It's the same thing. All right, now Excel does something that's a little bit annoying to me, which is it always plots box plots this way, vertically oriented. I haven't been able to figure out how to swap that, at least without doing a lot of work. It'll make a lot of effort to get it rotated around. So we'll just deal with it being a vertical box plot. All right, so let's talk through what it's showing us. This axis is the point totals. Maybe I'll put that in. Add chart element, axis title, vertical. All right, so this is points. Let me get rid of the title. And let's make the font bigger. so it's easier to see. Okay. All right, so the 5-number summary represents these little lines. So this is the minimum value, which was, I think, 18. The next one is this line here, just below 30. Then there's the line in the middle of the box. We'll come back to the X in a second. And then there's the line at the top of the box. So this is the 25th percentile. 25% of the data is below this level. 50% of the data is below this level. 75% of the data is below this level. And then here we have the maximum. 100% of the data is below the maximum. All right, so you draw a box around the middle 50%. So 50% of the data is from just below 30 to just above 40 points. Now what about the X? You might be able to guess. That is the average. All right, so you notice the average, the mean was 35.1. That's where the X is located. When I'm using a box plot, I might want the average in there, or I might be using my median as the center. So let's see if there's a way to get rid of that. I think we have to click on the data itself. Okay, so I've clicked on the box plot, the actual box where it's highlighted the points. And then under Format Data Series, I can come to the Chart tab, and it gives me some options. If there are outliers, you can have them removed. Show mean markers, that is the X. It's plural here because you can make multiple box plots. Actually, let me go to a different page here. All right, so you'll see these graphs on the answers to the example worksheet. So I have multiple box plots on the same chart. And so you can have mean markers for all of them. I don't need to have it here, so let me uncheck that. You can also make it a mean line, so it'll put a line there. I think it's not showing because the box is a little dark. Actually, why don't we change that? The box is a little dark. It's hard to see where the median line is. So I can change it from automatic setting to a solid fill, and I'll make it a little more transparent. I think that looks a little better. Okay, so we have a box plot, and we can think about the data in this way. This is sort of a visualization of how the data is spread out. Most of the 50% of the data is inside the box. 50% is outside of the box, and the range is from here to here. So a box plot gives you a quick understanding of how the data is spread out. All right. Another way to look at the data is by measuring the mean in the standard deviation as the measure of spread or measure of variation. So how do we get the standard deviation? Maybe I should have brought up the so this is the wrong thing. This is 6b. Okay, so I'll bring up the formula for standard deviation in the PowerPoint from section 6b, and we can take a look at the formula, and then I'll use the formula to enter in the data here in the spreadsheet. I guess while that's loading up, let me talk about the quick version of standard deviation. Also in the PowerPoint, it'll say there's like a quick way to estimate it, and that the standard deviation is about equal to the range divided by 4. So let me do that in here. Equals, so I'll make it equal to the range. And the range divided by 4 would be equal to that divided by 4. All right. And so as a quick rule of thumb, this will be a good estimate that the average value is 35, and you can sort of look at the spread of it as being plus or minus about 9.25. Going a little bit further, we can double this number, 2 times that, and the lowest value is expected to be equal to the mean minus 2 times the standard deviation. So by this rule of thumb, the lowest possible value in the data set should be around 16.6. It turns out that it's 18, so it's not a bad guess. And the highest would be equal to the mean plus 2 times the standard deviation. And that says the highest value would be around 53.6. So you can see that the rule works out pretty well. As a quick estimate of how the data is spread out around the mean, this works okay. Now the exact standard deviation, let's see, has a big old ugly formula like this. All right, so standard deviation is the square root of the sum, that's this symbol is the math symbol for a sum, of x minus x bar. X bar is the symbol for average value, or mean value. So I take each data point, subtract the mean, and square it. What's in parentheses here is the deviation, or what I call the deviation of each value from the mean. And so each value has a deviation from the mean, and then it gets squared. You add all of those up, and that's sort of an estimate of how much the data varies from the mean. Now, if every value is exactly on the mean, these will all be 0, and you'd have 0 variation. But then to make the standard deviation be something of an average variation, because you squared here and you've added them all up, you need to divide by the sample size. Now, for a technical reason I'm not going to get into right now, it's actually the sample size minus 1. And then you square root at the very end. So this is what we want to do. Add up all the deviations squared, divide by n minus 1, and then take the square root. So complicated formula, but I want to walk you through it in Excel. All right, so I've made a table here for calculating the deviations squared. And so the deviation will be equal to, I'm going to put it in parentheses, each value minus the mean value, which is this one, and then squared. Okay, so you can look at the formula in here. You can also look at it up here. Now, each time I want to use the same mean value, and there's a trick for that. That's to put the letter with dollar signs around it. And what that means is that each time it updates the formula, when I drag it down, the dollar sign says keep the same column, C, and also keep the same row, 5, for this value. And it'll update C9 going down. So let me hit enter. Okay, so the deviation for this data point is 0.003. Now, dragging this down, I've calculated now the deviation for every point in the data set. Okay, so it's got every point in the data set. And if I click on any random one, what is it doing? It's taking C19, that's this cell, minus C5. So it's keeping the mean the same and then squaring it. All right, back to the formula for a second. Okay, so I've got the deviation squared. I know what the deviation squared is for every value in the data set. I want to add them all up and then divide by n minus 1 and then square root. So let's go back to Excel. All right, so let's add them all up first. Equals sum of all of these numbers. So that's adding up the deviations squared. And then to calculate the standard deviation, we do equals square root. In Excel, square root is SQRT. And I'm taking the square root of this sum divided by n minus 1. Now I already have n on this sheet. N was the sample size. I do need to put it in parentheses. So parentheses n minus 1. If I don't put that in parentheses, it will do cell D28 divide by cell C4. Do that first and then subtract 1. I don't want it to do that. I want it to do D28 divided by C4 minus 1. So it needs to be in parentheses. And then I also need to close parentheses for the square root. So it's going to square root whatever is in here. And I get an answer of 9.9. I can check that with the quick version. 9.9 is the official, the correct standard deviation. And my quick estimate was 9.25. So you can see it gives you a reasonable answer here. All right. So how can we talk about Michael Jordan's 1993 playoffs? Well, he averaged 35.1 points per game, and the standard deviation was 9.9 points per game. If we can round numbers, about 35 points per game with a standard deviation of 10. That means that his point totals varied from about 25 to about 45 for most of the games in the playoffs. All right. Now, I think that's all of the tools and tricks I wanted to hit on here. I think that covers the things that you're asked to do in section 6B with respect to making graphs of the data and calculations of standard deviation and range and all of those things. If there are elements of this you want in more detail or you need explained a little bit further, feel free to post that in the class forum, and I'm happy to make more videos and bring up more data sets and do more examples. But I'll let you let me know if that would be useful.